Good afternoon, ladies and gentlemen. We're getting started on the first-person shooter tutorial. Now, before we get started, we are going to be making this for just plain old PC build. I was going to do mobile, but that's a whole nother set of issues that we got to get into, so I just want this tutorial to be basic so you can get a really simple first-person shooter going right off the bat. Alright. All of the assets that I'm going to be using for this tutorial are going to be just, freely available. They're going to be free assets on like the asset store or wherever I can find them. And all the links are going to be in the description for you to find. So the first set of assets are going to be the beta assets that Unity just recently released. The reason I'm using those is because they have some pre-built levels, some super derp assets for that, and they also have some half-decent first-person shooter scripts. So this first tutorial isn't exactly starting from scratch on a first-person shooter script, but I'm basically going to recreate the scripts for you and explain what they do. Because it's great and all to be able to use a script, but when you're making something like a game, you want to know how every single individual object is working, because if you come across issues down the road, you don't want to just walk into a script that you downloaded off the internet and not know what's going on. So I simplified the scripts, and I'm going to go through what each script is going to do. So once you download the sample assets, we're going to go into, where's those levels? Sample scenes. Let's go into the first person sandbox. And in there, they're already going to have a first person character. So what we're going to do is recreate this first person character. And I'm going to go, like I said, go through every single aspect. So once we hit play, get rid of these stats. I'm going to be able to walk around, going to get the head bobbing going, be able to run, and all that good stuff. So, yeah. So we're going to basically recreate the first person character, the simple mouse rotator, and the head bob. Alright. So let's create a new folder. So right click in your project window, create folder, and we'll just call it My Scripts. And the very first script I want to create is the rotation that's controlled by the mouse. So we'll just call this script Simple Rotator. And we'll double click on that bad boy, open it up. Alright, so just as a habit, I usually get rid of this stuff. You don't have to. So the first thing we're going to do is declare some variables that are going to be used throughout the script. The first one that we're going to declare is going to be a vector2 called rotation range. And it's just going to be the range that we're going to allow the camera to, or whatever object is using the script, to rotate in between. And we want to change it in the editor, so we'll make it public, and vector2, and we'll call it rotation range. And we'll just give it a default value of, say, 70 and 70. Oh, helps if I can type. Alright. And the next variable is going to be a multiplier for the rotation speed. That way we can, in the editor, if it's moving too slow, we can bump up the value and we won't have to modify the scripts. So public float rotation speed, and we'll set that to about 10. Alright. The next one is damping time, and the damping time is going to be how quickly the rotation stops. So the way we're going to set up the script is we're going to have two modes. One is going to be a relative motion mode, and the other one's just going to be a basic mode. And with the relative motion, it's going to kind of ease the rotation around, and this damping speed is going to determine how quickly the easing stops. So public float damping time, and we'll set that to 0.2 just for now. And like I said, we're going to do two modes, which is relative motion and just basic motion, and we want to have a toggle for that. So we'll go public bool relative equals true, and we'll just default it so it's using relative motion because it looks better. Okay, so these four variables are going to be accessible from the editor. They're going to be things that we want to be able to manipulate, and we're going to create a couple new variables that are only going to be used inside the script, and they're not going to be modifiable anywhere else. So these are going to be private instead. So the first one we want to make is a vector 3 called target angles. And what target angles is going to do is it's going to be a value that the rotation is going to try and move towards. So as we're moving the mouse around and rotating, it's going to set the value of, it's going to be the final value that the camera is going to rotate to, that the camera is going to kind of ease into. Okay, so we want to make it a vector 3, and we'll call it target angles. And we're going to create another vector 3, and we're going to call it follow angles. And what follow angles does is it's going to be the actual rotation of the camera at a point in time. So where target angles is the final rotation, follow angles is going to be the rotation of the camera that we calculate during the update. So it's going to be what you see at a certain point. And we'll go make another vector 3, and this is going to be follow velocity. Alright, so this one is basically going to be how quickly the camera is going to be rotating around and trying to get to target angles. So follow velocity is going to be calculated using the damping time, rotation speed, and it's going to be applied to follow angles. And we are going to create a quaternion. We'll make that private. And we're going to call it original rotation. So this script is going to work from a local standpoint. So we want to, if we're going to rotate, say, if we're going to limit the rotation, say 70 degrees, we want it to work from the object's original rotation. That way it doesn't snap to the left or snap to the right when you hit play. So we're going to store the original rotation and then do all the manipulation from to that value. Okay, so that's all the variables that we're going to be using for now. So now we can get started on the actual functions. So our first one is going to be our start function, and when the object starts, we're just going to store the rotation of the object in original rotation. So original rotation is equal to transform.rotation. Oh, wait, no, transform.local rotation, because we're doing this in local space. Okay, and that's all we got to do in start. Update is the big function where everything happens, so we'll get started on that. So void update, and alright, so what we're going to do right now is we're going to create two float variables. One's going to be called horizontal input, and the other is going to be called vertical input. And what we're going to do is we're going to take the mouse values and we're going to store them in these two floats. Alright, so first thing we want to do is create an if statement, and we're going to take care of what's going on when we're using relative movement. So if relative, and inside our if statement, we're going to assign the values to horizontal and vertical input. So horizontal input is equal to the input class dot get axis, and in get axis we are going to enter mouse x. Alright, so if you've never used the input class before, or if you've never used get axis, basically what this function does is it grabs a key, which you enter here, from the input manager and returns the current value for that key. Now if you're you can define your own axes in Unity, so we'll just go in Unity real quick, go into project settings and input, and we get the input manager here, and you see this little tab here for axes, and here you'll see a whole bunch of different things defined, and you see our mouse X and mouse Y, which is what we're going to be using in this class. Now if we click on mouse X to see what it does, we can define a whole bunch of stuff in here, but what you'll see is the type is mouse movement. So what it's going to be doing is it's going to be detecting how much the mouse has moved from the previous frame to the current frame on the x-axis. So when we say input.getAxis mouse x, it's going to ask the input manager how much the mouse has moved on the x-axis in the last frame. Alright, isn't that fancy, guys? So what we're going to do the exact same thing for the vertical input, except it's going to be using mouse y. So get axis mouse y. Alright, so when we hit play, it'll return a value depending on how far the mouse has moved in the last frame. Alright, so what we want to do here, now that we got the horizontal input and whatever, is we are going to try and clamp our target angles vector between 0 and 360 degrees. So we don't want the values to go crazy if you start spinning around and going nuts. So we want to make sure that the values are between negative 360 and 360, just to kind of clean things up and keep it easier to manage. So what we're going to do is I'm going to make an if statement, and we'll go if target angles dot y is greater than 180. We're going to go target angles dot y minus equals 360, and follow angles dot y minus equals 360. Alright, so we check to see if the target angles rotation on the y-axis, which is the vertical axis, so when it rotates it's going to be going this way, which is, you know, your horizontal. If it's greater than 180 degrees, we're going to minus 360, just to kind of keep it between 360 degrees. Okay? And else, if target angles dot y is less than minus 180 degrees, we'll just copy and paste that in there. But in this time we're going to do plus equals. Alright, so I kind of messed up earlier. We're not keeping it between negative 360 and positive 360. We're keeping it between negative 180 and positive 180. That way the whole rotation is going to be clamped in 360 degrees in total. Alright, so if you rotate to the left, past 180 degrees, we're going to add 360 degrees. That way, instead of being negative 190 degrees, you're going to be positive 190 degrees. That way you can keep going, and it'll be it'll be a consistent value. All right. The next thing, we want to do the same thing, but we want to do it to target angles x-axis. Now the x-axis is going to be your left and right axis if you're looking straight. So if you're rotating on your left and right axis, it's going to be your up and down. Right? So we want to keep that from going too far. Otherwise, you're doing somersaults while you're running. So if target angles.x is greater than 180. Whatever. We'll just copy and paste that in there and change the y to x. Right. And we can actually copy and paste this too and change all the y's to x because it's the exact same code. Alright. Alright, so now that we have that taken care of, we can actually start calculating what the camera's rotation is going to be. So we're going to start manipulating the target angles value. So we'll go target angles dot y plus equals horizontal input times rotation speed. All right, so the horizontal input, remember, is going to be the distance at the most moved compared to the last frame, and it's going to multiply that by the rotation speed. So this is going to be a relative motion, and it's going to be rotating left and right based on how far you moved your mouse from the last frame. Okay, and we'll do the exact same thing for the x value, plus equals vertical input times rotation speed. Alright. Now, remember how we made this rotation range? Here we're going to clamp the values. And clamping is basically just meaning if it's greater than the maximum value, we'll set it to the maximum value, and if it's less than the minimum value, we'll set it to the min value. Alright, so first we're going to clamp the y rotation, the left and right. So target angles.y equals, I'm going to use the mathf class .clamp, and we're going to go negative 0.5f times the rotation range. Rotation range. What's going on here? Yeah, we'll just copy this. Rotation range dot y. All right. So we're clamping to the left half of the rotation range, and we'll go 0.5f times rotation. For some reason that's not showing up in IntelliSense and it's throwing me off. Alright, so now that we've added these values to the target angles, we want to clamp the values between to our rotation range. So let's say we have a 70-degree rotation range. We want to clamp it between 35 degrees to the left and 35 degrees to the right. That way we have 70 degrees of rotation. Right, so to do this, we're going to go target angles.y equals mathf, the math class, .clamp, and we'll go the value that is being clamped, which is target angles.y, and the minimum value, which is going to be half of the range to the left. So we'll go rotation range.y times negative 0.5f, so half, to the left, and then rotation range dot y times 0.5f. Right, so minimum value is half the rotation range to the left, and then max is half the rotation range to the right. All right, and we're going to clamp the x rotation too. So target angles dot x is mathf dot clamp target angles dot x rotation range dot x times negative 0.5f, and exact same thing except positive 0.5. Alright, so now we're clamping the left and the right. Alright, and using relative motion, we have our target angles set. Alright, so why did I put that out here? Alright, before we move on, copy or cut and paste this inside relative. I must have had a brain fart and started putting it outside. But this is supposed to be calculated while you're detecting your relative motion. Alright, so we grab the input, make sure it's between negative 180 and 180, set the target angles, and we clamp it between the range. Okay. Now, if we're not using relative motion, we're going to be getting the actual position of the mouse on the screen and using that to figure out how far you've rotated. This is a little bit of a jerkier rotation, but it's exact of where you are on the screen instead of where you were last frame. Alright, so now, if it's relative, we do this, else we'll go horizontal input is equal to the input class, mouse position, so we're getting the actual mouse position. Alright, and same with vertical input. Input.mouse position dot y. Alright, so here we got the relative position, and here we're getting the exact position. And we're going to do close to the same thing. Instead of clamping it, we're going to lerp it between we're going to lerp between the maximum or the minimum range and the maximum range based on the screen width and height. Okay, and lerp means linear interpolation. So if I was to enter like 0 and 100, and I wanted to have the linear interpolation of those numbers, if I entered 0.5, it would give me the halfway point. If I entered 0.1, it would give me 1/10 of the way. All right, so what we're doing is we're going to take the x's or the mouse's position on the x and y and divide it by the whole screen width and height, and that'll give us the position of the mouse in 0 to 1 coordinates, and that's going to determine where our mouse is going, or how far we're going to be rotated from the minimum to the maximum. Okay, so we're going to go target angles dot y. So we're doing our left and right motion is equal to mathf dot lerp, and from is going to be the rotation range dot y times negative 0.5f. The 2 is going to be all the way to the right, so rotation range dot y times 0.5f. And our t, which is going to be the 0.1 or the 0.5 that we enter into our linear interpolation, is going to be our horizontal input divided by screen dot width. Alright, so if our mouse position is halfway from, like halfway in the screen, it's going to enter 0.5, and it's going to be the halfway point between our left, our minimum rotation, and our maximum rotation. So we should be directly center. Okay, so target angles.x is equal to mathf.lerp rotation range.x times negative 0.5f rotation range.x times 0.5f, and this is going to be vertical input divided by screen dot height. Alright, so we have our target angles now. Now we'll figure out our follow angles and where the camera is actually going to be looking at. Alright, so here we calculate our follow angles outside of the if statement. We'll go follow angles is equal to vector 3 dot smooth damp, and we're going to use the old follow angles value and then the target angles. We're going to use a ref value for follow velocity, and we're going to pass in the damping time. Alright, now this keyword here means that we're going to pass in the object using a reference. So anything that happens in this smooth damp function will actually physically modify this value. Now when you're doing methods normally, using classes like vector2 or whatever, if you pass them into a function, its parameters, it passes it by value instead of reference. And the difference is, if you change something to the reference, it'll be changed throughout your code. But if you pass something in by value, it makes a copy of it, so you can do whatever you want to that, and it won't modify the original object. So when we're trying to do something to a vector 3, and we want to modify, or if we're passing a vector 3 or a struct into a function, and we want to actually modify it, so we can use that anywhere else in the code, we can pass in this ref keyword beforehand, and it'll actually be a reference of that object instead of the value. Okay. So we calculated our follow angles, and now we're going to actually physically manipulate the rotation of the object. So we'll go transform.rotation is equal to our original rotation times quaternion dot Euler, go negative follow angles dot x follow angles dot y and 0. Alright, so what is this doing? Basically what is happening here is it's taking our original rotation that we got up here, and it's multiplying it by a new quaternion that we calculate using this Euler function. And so what this function does is we pass it in Euler angles, which is going to be our follow angles that we calculated, and it's going to calculate a quaternion out of that. And a quaternion is basically just another way to calculate rotation and that sort of thing. And it's a lot faster to do it that way than to sit here and use Euler angles. And basically it's a much quicker way to do rotation programmatically. So that's how we do it. And so we basically calculate a rotation out of our Euler angles, and we multiply it by the original, and that'll give us our current rotation of what we're trying to look at. Oh, and before I forget, this needs to be not rotation, but local rotation, because we're doing this in local space, remember. Alright, so now, if we deactivate the simple mouse rotator, and we add our SimpleRotator to the object by just dragging it on, have to remember. Fuck. Alright, no, let's just start over. Alright, so now that we calculated the follow angles, we're going to actually apply the rotation to the object. So what we're going to do is we're going to manipulate the local rotation of the object. So transform dot local rotation is equal to our original rotation, and we're going to multiply it by a function in the quaternion class. It's called quaternion dot Euler. And in this Euler function, we're going to pass in our follow angles. So, except it's going to be slightly different. We're going to go negative follow angles dot x, follow angles dot y, and 0. The only reason we do that is because we want to make sure that there's no rotation on the z-axis, which is going to be kind of the guy rotating this way. And we apply a negative follow angles. That way, when we rotate to the right with our mouse, the guy actually rotates to the right. Because if we don't, if we keep it positive as we move our mouse to the right, the thing is going to rotate to the left. So we just apply a negative there to make sure it follows our mouse. All right. So that's it for the simple rotator. If we go into our script and say we remove the component simple rotator from the first person character and we add our own, we'll manipulate the properties here. We want to have a different rotation range. So it defaults to 70-70. And when we're manipulating the character, we only want him to be able to rotate to the left and right. That way he's not, floating up and down or, whatever. So we're going to set the X rotation range to 0. That way he's only rotating to the left and right. And we'll set the Y rotation range to just a big number. That way he can rotate all the way around and we don't have to worry about him catching on anything. Alright. And we also need to attach a SimpleRotator script to the first person camera. And the reason we do that is so that the guy can look up and down. We clamp it to 0 for the up and down rotation on the first person character, like I said, because if we start looking up with the actual character, he's going to start floating in the air as we're trying to run, and we don't really want that. So we take care of it by attaching it to the camera instead. That way the camera can look up and down, and it's not going to affect the rotation of the character at all. So get rid of the simple mouse script and attach ours. And the rotation range for the camera is going to be 170 for the X, so to look up and down. If we set it any higher, it's going to start looking like he's somersaulting a little bit. And the Y is going to be 0. That way the camera only rotates up and down. So if we hit play, we should get what we had before, where we can look around, move, and now we understand what the SimpleRotator script actually does a little bit better. Alright, and I think that's good for now. I'm actually going to I'm going to do 3 videos for the 3 scripts. The only reason I'm doing that is because I think this video is going to actually get a little long if I do all 3 at once. And like I have a couple guidelines here of just what I want to go over with the script. And yeah, I don't want this to be an hour-long tutorial just for a couple scripts. So I'm going to split it up. I'm going to release all 3 videos on the exact same day. That way they're all there. That way you guys can kind of go through the script at any point. You don't need to worry about hitting certain times or whatever. It's just right there for you. And I feel like it would be better to do it that way. So I guess I'll be right back with the first person character script. So the next thing I wanted to go over with you guys was the first person character script, the one that actually lets you move